You're welcome back to the continuation of the functions of the quadratic functions, as regards their sketches and their range. Now, in the last video produced, we solved a problem as an example on how to sketch a quadratic function and determine their range. But unfortunately, we did not we did not answer the second question. That was an oversight anyway. So let me recall the graph so that we quickly solve that problem. So this is how the graph looks like in the previous video. Yes, something like this. I think our 1 is here. It is 1, minus 4. You have 3 here. You have minus 1 here. It was an oversight. Apologies for that. So now, how do we get the domain? The domain of that function, I told you, is a set of what? Is a set of x values. These are our x-axis, these are our y-axis. Y positive, x positive, y negative, x negative. So obviously, as far as this curve is concerned, this exists where? Minus 1 and 3. This is the range of this function. The values of x for this parabola. Remember, it's a minimum what? It's a minimum quadratic function. Now, for the range, fine. For the range now, don't forget the range of a function is a set of y values. The set of y values of that function, the elements in the codomain, form the range of the function. Those that are marked by the domain. Now, what are our y here? You can see that we have the y here is minus 4. Because this is 1 and minus 4. So we pick it from minus 4. Yes, minus 4 is there. And look at it up there. Up there. You see that all other values of y here will be positive. Yes, they will be positive. Because it minimum means it doesn't go down again. This is the minimum. So that will be what? Infinity. If you like my close, test it. So you can open it up, close it. So, well, for the sake of the clarity, for clarity's sake, let's close it. So that is that about that. Okay, now quickly going through the given problem. This is just what we forgot to do in the previous video. Now, how do we solve this problem? How do we solve this problem? Following the first method we used in the previous video, we have a solution. Our f of x is minus 2x squared plus 4x minus 5. That is our given problem. That's the given problem. So we can say that, let's factor out minus 2 into x squared. I think it's minus 2x minus 5. Yes, let's factor it out like that. So which could be equal to minus 2 into, now we find a way of using the complete square method to factor this out so that we'll be able to get a complete square. So just like we did the other time, just say x squared minus 2x plus the coefficient of minus 2, minus 12 over 2 squared. That'll give us x squared minus 2x plus 1. So the factor now is x minus 1. They ask, how did I get minus 1? Fine. Here, the square root of x squared is x. The square root of what you have here is minus 1. That was why you have to make sure you include minus 1 here. Don't just add it. Don't just multiply square by saying that, okay, it's minus 1 now. Let me just, minus 1 square should be 1. No. Yes, of course, minus 1 square is 1. But while you are doing your calculations, don't forget that the coefficient of x here is minus 2, not 2. So that's why it's minus 2 over 2, so minus 1. So pair it up with that. So you have x minus 1 squared. Okay, x minus 1 squared. Now, but don't forget, x minus 1 squared has given us what? X squared minus 2x plus 1 by expansion. But what we have here, what we need here is what? Is x squared minus 2x. How do we now remove this 1? It will be minus 1. How? I hope we are not confused. Using complete square method, we get x minus 1 squared. And the expansion of x minus 1 squared is this. So fine. But the original problem or function here is x squared minus 2x. And we have gotten additional, 1 has been added to it. 1 has made this one to increase. So we have to remove that 1. By the time you remove 1 from here now, plus 1 minus 1, it will come back to this. So that's what I did there. So you have x minus 1 all squared minus 1 minus 5. It's as simple as that. It's as simple as that. Okay? Now, with that, what next? Okay? We can now say that this is minus 2, expansion, x minus 1 squared minus 3. How? Why? Okay? If you expand this, minus 2, minus 2 times minus 1, that's plus 2. Plus 2 minus 5 minus 3. It's just expansion, using minus 2 to expand. Obviously, now the point at which the function, this is going to be maximum function because our a is negative. So the maximum point for this function will occur at minus 1 and what? And at 1 and minus 3. So that's it. Now say the maximum point of the given function will be at 1 and minus 3. Yes, I hope you understood what I did there. Just like the first example we did, or we solved. X minus 1 equals 0, x equals to 1. And the corresponding value of y will be minus 3. That's just that. Okay, that's the point at which the maximum function occurs. So you can quickly draw that, sketch that. You can sketch that now. Let's sketch that. And if you could factorize that expression, you go along. Okay. Now let's quickly do that now. It will be like this. We have 1 and minus 3. 1 for x, minus 3 for y. Let's say this is minus 3. We didn't go ahead we didn't use factorization this time, and I will show you why we're not using it. Now this is 1. 1 for x axis, y axis. 1, then 0.1 here. Its corresponding value of y is minus 3. So that means somewhere here. Exactly. This is 3 for y. It's minus 3 for y. This is 1. Okay, that's the 1 for x. Obviously, you will see that this graph does not have x values. It doesn't cut x values. It doesn't cut x values. Not does not have x values. Sorry, it does not cut x values. It is not like this graph, like this. This one cuts x values here and here. But this one, unfortunately, it doesn't cut x values. How did we know? Why? The first thing you always do is to find the maximum point. Once you are able to get the maximum point, you will know whether it cuts the x values or not. So since it doesn't cut the x value, you don't need to worry yourself by looking for the values of x for the graph. So now, that means, what do you write as the range? Nothing. So now, as the domain, nothing. Now, what do you write as the range of the graph? Negative infinity minus 3. How? See, this is the peak of the graph, maximum point for y, minus 3. Then going down, see that minus 3 is the maximum. You can't get more than this. So that's why minus 3 is included. But for x, the values of x corresponding to this one. Now, if you look at it holistically, it doesn't cut x axis. Fine. And y goes down. It means that if this is maximum, you can have all the values here are minimum. So minus infinity and minus 3. Don't forget, the range of a function is a set of y values. So this is for y. Are you getting now? We are not looking for the domain. If you had been asked to look for the domain now, the domain of this function is what? What we call the domain of this function is a set of x values. So it's a set of real numbers. Yeah, real numbers. That it doesn't cut x axis does not mean it doesn't have x values. So don't get it wrong. No. It has x values, but it does not cut it at any point. So, but the range of the function, if this is the maximum, every other values will be minimum. That implies that it has continuously have a negative value. So you start with negative infinity and close up at negative 3. So on this note, we call this one a day. So in the next video, we shall talk about something else different from this. So don't forget to click on the notification button so that each time I produce new video, you'll be notified. Thank you.